I like to METWET, METWET. You like to METWET, METWET. They like to METWET, METWET. We like to METWET. That's right, my friends. Today is all about getting some practice with and seeing two neat little extensions of our fancy strategy for multiplying polynomials together. Let's do some METWET. Class 3, Unit 7, Multiplying Polynomials, Part 2. Now remember, when we're multiplying polynomials, there are three methods that we can deploy, all of equal value. I want you to pick your favorite of the three and use it to find the product of 2u minus 7v and 4u minus 5v. Once you think you've got it, come back, check your work with me. We will do all three of these methods together. Take a minute, pause the video, go find your product. Have fun! Okay, thinking chronologically, the first way that we learned, well, I can take either of my factors, doesn't matter which one, using the distributive property, right? I can give this whole factor to each of the terms in the other factor. So I can take, in this case, if I distribute the 2u minus 7v, I can take 4u and multiply it by 2u minus 7v, and I can take negative 5v, and I can multiply it by 2u minus 7v. But now that I'm here, you'll notice I'm now in a position where I can do a second round of the distributive property. Hence our name for this method. You may recall we dubbed it our double distribution method. I'm doing two layers of the distributive property. Well, doing my second layer here, I need to do 4u, hey, for me, times 2u. Well, let me, again, trying to do this in my head, think about what I know. Well, 4 times 2 I know how to do, that's 8. U times u I know how to do, that's u squared. 4u times negative 7v, I can do 4 times negative 7, that's negative 28. And u times v, well, that's just uv. Negative 5v times 2u, well, negative 5 times 2 is negative 10. V times u, writing that alphabetically, I can say that's another uv. Then I've got negative 5v times negative 7v. Negative 5 times negative 7 gives me positive 35. V times v is v squared. Last move, all I need to do is combine any like terms that I see. Well, I can't do anything with the 8u squared, but negative 28uv minus 10uv, it's getting more negative. That's negative 38uv. Hey, that's a lot of sun. You might want to put on some sunscreen. And then I've got that straggling 35v squared at the end. There you go. There's your final answer. Cool. But we also know that there is a much more efficient way to do double distribution. We saw last time that this is exactly the same thing as taking each of the terms from our first factor and multiplying it with each of the terms in our second factor. I can distribute each thing from the first one individually. Hence the name for our second funky, friendly method, this guy, is our good friend METWET. Now, we are not going to call it the dirty 4-letter F word that you cannot say in math class. There's only one of them. This is, has been, always will be, METWET and nothing else. So, starting with that 2u, I'm going to distribute it to 4u. 2u times 4u, well, there's our 8u squared. Distributing 2u to negative 5v, there's our negative 10uv. I've got negative 7v times 4u, there's our negative 28uv. And then at the end, negative 7v, distributing that to negative 5v, there's my positive 35v squared. Again, all I've got to do is combine my like terms. Would you look at that? 8u squared minus 38uv plus 35v squared is still our final answer. And last but certainly not least, for the more visually inclined among us, when we were together last time, we also saw that we could repurpose our area model for multiplication from previous points in our mathematical journey and reuse it here to make some sense of polynomial multiplication. So what I'm going to do, I'm going to give myself a nice little rectangle. We're going to pretend that this rectangle is composed of entirely straight, beautiful, perfect lines. Honestly, that's not too bad for me. And what I'm going to do, I'm going to take each of the terms from my first factor and here layer them up on the top. Each of the terms from my second factor here is going to get slotted into place on the side. Now, I just need to find the area of each of my little rectangles. Well, that's just length times width. So on the top left, that would be 2u times 4u. Look at that. There's our 8u squared. Top right, there's our negative 28uv. Bottom left, there's our negative 10 uv. And bottom right, there's our positive 35 v squared. All I've got to do is find the area of this whole rectangle. Well, if I add up all of these little subchunks, that should give me the total area of my rectangle. All I've got to do now is combine any like terms that I see. Well, there, it's a Christmas miracle, is my final answer from before. Magnificent. Either way we see, all three of these methods are interchangeable. They all get us to the same place. Just a matter of preference. So using whichever one is your preference, let's do two more together to make sure it really sinks in. Let's start with the product of 3x minus 5 and 2x plus 1. Go ahead. And stop. For me, my favorite is METWET, not just because it's the most fun to say, but also because it's the most efficient. So I'm going to start by distributing 3x to each of the terms in my second factor, and then I'm going to take the negative 5 and distribute that to each of the terms in my second factor. Starting with 3x times 2x, well, 3 times 2 is 6, x times x is x squared. 3x times positive 1, there's plus 3x. Negative 5 times 2x, there's negative 10x. And negative 5 times 1, there's negative 5. Once again, I see like terms, I put them together. 6x squared minus 7x minus 5 is my final answer. One more for the road. Let's take this guy. Y minus 2 times the quantity y squared minus 3y plus 4. Again, use whichever method you prefer. Go ahead. Alrighty. I did METWET last time, and as much as I like it, let's do some variety. Why not? I'll do double distribution. Let's take this y minus 2. I'm going to give it to each of the terms in my second factor using the distributive property. So I've got a y squared that I'm going to attach y minus 2 to. I've got a negative 3y that I'm going to attach y minus 2 to. And I've got a 4 that I'm going to attach a y minus 2 to. Now I've just got to do my second layer of the distributive property. So from here, y squared times y, there's y cubed. Y squared times negative 2, well, that's just negative 2y squared. Negative 3y times y is y squared. And negative 3y times negative 2 should be positive 6y. Last up, I've got 4 times y, so there's 4y. And 4 times negative 2 is negative 8. Once again, in order to fully simplify, I just need to combine my like terms. So that y cubed is hanging out by itself. I can put together negative 2y squared and negative 3y squared. That gives me a total of negative 5y squared. I can do 6y plus 4y. That gives me 10 y's in total. And attach my negative 8 at the end. There you go. There's your final polynomial. Magnificent. Now, in doing enough METWET, I promised you two neat little extensions. You're about to get them. We'll discover that there are a couple of so-called special patterns that can be really helpful if we commit to memory. Either way, they show up so frequently that we generalize the process of simplifying them. Now, given polynomials, one thing that you might ask yourself is, what happens if I multiply a polynomial by itself? This is going to give us the first of our special patterns, or sometimes special products. Now, if I take a plus b quantity squared, by the way, both of these patterns are going to appear just for binomials. In other words, just with two terms. Now, what would it be really nice if a plus b quantity squared was equal to, or a minus b quantity squared was equal to? Again, the a and the b are here going to stand in for anything that could be in these slots. Well, it would be really great if this was a squared plus b squared. If just like coefficients, I could distribute exponents. But we, of course, know from Unit 6 that we cannot distribute exponents. It is unfortunately not within the realm of possibility here for us to make this choice. So Neither of these are going to be our right answer. How might I think about expanding a plus b quantity squared, or a minus b quantity squared? And once you've got it, see if you can do some METWET, to figure out what your final product should be. Take a minute, play around, see what you come up with. Go, go. And stop. So a plus b quantity squared, it does not mean a squared plus b squared. If I think about the definition of an exponent, squaring something means to multiply it by itself. So I hope you agree that a plus b quantity squared really means a plus b times a plus b. And now I'm here, I can METWET. Well, doing my METWET here. A times a gives me a squared. A times b gives me positive ab. B times a, once again arranging alphabetically, there's my positive ab. And then I've got b times b, which is b squared. Look at that, I've got some like terms I can combine. ab plus ab, so I've got a squared. Actually, let me write this in green. Here's our final product. This is a squared plus, combining my like terms, 2ab plus b squared. So this is the same as a plus b quantity squared. We've just proven it using METWET. We can do exactly the same here with a minus b quantity squared. Again, by the definition of an exponent, what this really means is a minus b times itself. Doing some METWET, I can now take a and distribute it, take negative b and distribute it. Doing my distribution, a times a is still a squared, but a times negative b is now negative ab. Same thing with negative b times a, it's still negative ab. And negative b times negative b, those negatives cancel, I've got positive b squared. Last move, combining my like terms, let me also put this guy in green. I've got a squared by itself, negative ab with another negative ab, so I've got negative 2ab, and then my plus b squared at the end. So this guy is the same as a minus b quantity squared. It's a special pattern that now that we've shown it, we can use it in any case where this is happening. There's a special name that we give this special pattern. You'll notice it comes from multiplying something by itself, which means that it's a perfect square. And you'll notice that both of these have 3 terms, which makes them trinomials. So, perhaps unsurprisingly, putting those two pieces of terminology together, we are going to call these things our perfect square trinomials. They are trinomials that result from multiplying a binomial by itself. Cool. Let me give you 2 examples here. You can use your special pattern or you can use METWET here. Let's simplify each of our products. Go ahead. And stop. So let me show you both methods here. If I take 5m plus 6, I know that by definition, this means 5m plus 6 times 5m plus 6. And now, all I gotta do is a METWET. So 5m times 5m, 5 times 5 is 25, m times m is m squared. 5m times 6 is 30m. 6 times 5m is still 30m. And 6 times 6 is 36. Once again, I can combine some like terms here. This is 25m squared plus 60m plus 36. But we can also do this using our special pattern. Well, I know that this is going to be a perfect square trinomial, so it needs to fit into this pattern of a squared plus 2ab plus b squared. Well, in the thing above, notice that the thing in the a slot at the front was 5m. The thing in the b slot was 6. So if I do some substitution, I can rewrite this using my special pattern as 5m squared plus 2 times a, which was 5m, times b, which was 6, and then b squared would be 6 squared. Multiplying, right? 5m squared means 5m times 5m, so there's my 25m squared. 2 times 5m is 10m, times 6, there's my 60m. And then I've got 6 squared at the end, there's my 36. I hope you can agree that these two are the same. Doing my second one, 2n minus 7 squared, for the sake of practice, let's use our special pattern. So I know here that this guy is going to be my negative version of my pattern. So this is a squared minus 2ab plus b squared. The thing in the a slot is the 2n. The thing in the b slot is the 7. Doing some substitution, all I got to do, well, I'm going to replace a with 2n. So this is 2n squared. I've got 2 times 2n times 7. And then I've got b squared, which is just 7 squared. Doing my multiplication. 2n squared means 2n times 2n. So this is 4n squared. I've got negative 2 times 2n, which is negative 4n, times 7 gives me negative 28n. And then I've got 7 squared at the end. This is plus 49. Magnificent. Now, we've seen what happens when I do an a plus b times an a plus b. We've seen an a minus b times an a minus b. Last case would be an a plus b times an a minus b. Do some distributive property. Let's METWET. Can you tell me what this guy works out to be? Go! Alrighty, so I'm going to do some METWET. I'm going to take my a and distribute it, take my b and distribute it. Well, a times a, there's a squared. A times negative b is negative ab. B times a is positive ab. And then I've got positive b times negative b, that should be negative b squared. Well, would you look at that? Negative ab and ab, these cancel each other out. So in this case, this guy is left as just the square of the thing at the front minus the square of the thing at the back. In this case, you'll notice, right, it has a minus sign in between, so it's a difference, and it's differencing two perfect squares. So unsurprisingly, we are going to call this pattern a difference of, I can write a better of than that, difference of squares. It's a perfect square minus a perfect square. Take these two examples, and then we'll hit the road. Let's use our difference of squares pattern to work these out. Go! Okay, again, demonstrating both ways, right? I can do some METWET. I can do 4f distributed here and 3 distributed. Well, 4f times 4f, 4 times 4 is 16. F times f is f squared. 4f times negative 3, that's negative 12f. 3 times 4f is positive 12f, and 3 times negative 3 is negative 9. Look at that. Once again, the negative 12 and the 12 go away. I'm just left with 16f squared minus 9. But I can also take my difference of squares pattern, right? I know that this is going to be a squared minus b squared, whichever of these you prefer. Well, the thing in the a slot is the 2g. The thing in the h slot is the b. So all I need to do is take 2g and plug it in for a, minus h, which is going to get plugged in for b. Well, 2g squared is 2g times 2g, that's 4g squared, minus h squared. 4g squared minus h squared should be the same as what we would get from METWET.